Distinguished delegates from SAARC member states and respected audience, good morning, and I welcome you all on behalf of SAARC Energy Center. My name is Ahmed Talha, and I'm working for SEC as a Research Fellow Technology Transfer. I will function as a moderator for today's session on behalf of SEC. Thank you for joining us today for the webinar on how users can save on their electricity bills. I hope that you are all safe and are doing well. Dear audience, with the human population growth over the last 50 years and more rapid rise in urbanization, the demand of electricity is going to increase tremendously. Conservation of electricity and its efficient usage are the most cost-effective methods to meet this growing demand. This approach can result in reduced electricity bills, reduce our dependence on fossil fuels, as well as offset their adverse impact on our environment. Given the potential benefits of energy conservation, SAARC Energy Center decided to conduct a knowledge-sharing webinar under its thematic area of program to minimize oil imports through improvements in energy efficiency and fuel substation. We have brought together a panel of expert speakers from SAARC region who have vast experience in power system operations, particularly distribution sector, and they will enlighten our audience in various methods to minimize energy wastage and maximize energy savings. I certainly hope that it will be an intriguing session and will educate our audience on the important role in utilizing electricity efficiently. Dear audience, before proceeding with the agenda, I would like to draw your attention towards certain things related to this webinar. Please note that the agenda of this webinar is already available on SEC website, and you can also access it through GoToWebinar panel. All the presentations, a brief report on webinar and a webinar recording link will also be uploaded on SEC website in due course. Member of the audience can ask a question by typing questions on the GoToWebinar panel on your screen. You may send in your questions at any time during the presentation. We'll collect the questions and address them during the Q&A session at the end of each presentation. Due to time limitation, we apologize in advance if we are unable to address your question. Dear audience, we are now going to move to our first session of this webinar. Mr. G. Srinivasa Rao has joined us from East Coast Sustainable Private Limited, India, and he will be presenting on electricity saving opportunities in industrial and commercial sectors. Mr. Rao is currently working as Director of East Coast Sustainable. He has got experience in energy sector covering technical, commercial, and regulatory aspects of power generation, transmission, and distribution of electricity and energy efficiency. He has also consulted industries to optimize their energy cost, improving performance of various industry sectors such as MSME, thermal power plant, cement, iron, steel, fertilizers, pharmaceuticals, municipalities, and commercial buildings. His expertise include technical consulting, financial engineering, transactional advisory, sourcing, project management for implementation of energy efficient solutions, electricity tariffs, and regulations. Welcome and good morning, Sir Srinivasa Rao. Thank you for joining us today for this webinar. The floor is yours. Please begin your presentation.
Yeah, thank you, Mr. Ahmad, and thank you one and all for joining this webinar. The time given to me is 30 minutes.
So can you please share your screen?
Yeah. Yeah. We are sharing the screen. Video you are saying? Yeah, I'm sharing that. No one sees your session. Or you could. Can you hear me, Mr. Ahmad?
Yes, sir. Yes, sir. We can see your screen now. Yes.
Okay, fine. So can I proceed?
Yes, sir.
So I will quickly go into this. Again, it has come into a different mode. It's not full screen. Yeah. Yeah, thank you once again. Okay, so I have outlined my presentation with some introductory slides about the electricity scenario and some of the productivity indicators, and then some regulatory and legal structures that are available. And most of the presentation I am speaking from Indian experience. Maybe quite of the audience may be from India, so for them it may be quite familiar these things. Especially the government of India is doing a lot of awareness workshops, and even the slides what I'm using now are from my previous presentations which I conducted as a faculty for Bureau of Energy Efficiency for their refresher course for energy auditors and energy managers. But having said that, this is like a common minimum program, minimum things I will be talking. But anybody wants to deliberate little more into details, that we can save it for question and answer sessions. So with that, I just start with some introductory slides about electricity scenario. Yeah. So what's happening here? Slideshow. Yeah. Before that, we have one. Yeah, this one. The first slide. This one. Okay. Yeah. Yeah. So many of the developing countries have this issue that most of their power generation, the electricity generation from the fossil fuels. Now, why we are interested in energy efficiency is earlier when I started my career, it is because of the cost considerations. The energy cost is increasing and dependence on oil imports. So these were the issues. But as the time lapsed, the major factor has come into play, that is your climate change and global warming. So now we can say that the most of the energy efficiency projects, the thinking, the policy making, everything is revolving around this climate change. But whether climate change is there or not, the industry and other businesses, they're always been very keen on implementing these energy efficiency projects for the purpose of cost reduction. And the importance can be summarized like this. If you are doing good, if your economy is doing good, then you need energy efficiency because of the environmental considerations. If it is not so good, then you anyway need energy efficiency to optimize their cost. So whatever may be the economic situation, this topic and the need for energy efficiency is evergreen. It's ever required. So with that, the slide only says that most of India's energy requirement, electricity, is coming from fossil fuel, more than 80%, and balance is coming from renewable, hydro, and nuclear. So this is what this slide says. And coming to my next slide is how this electricity is consumed in various sectors of the economy. Mostly it is industry, and then domestic, and India being an agriculture country, that's also a major chunk. And last but not the least, the commercial. Okay. And commercial and residential, these two have a interlinked relation, because most of the technologies, first they will start at one of these, either domestic or commercial, and then they will travel to other sectors. Okay. So if there is a efficiency chiller, you may start finding its way in commercial, and then slowly it will percolate to the domestic sector. So I would club these two under buildings, and if you and the today's topic is aptly selected. So if you put these three together, it's a major chunk.
Excuse me, sorry to interrupt. Can you please minimize the GoToWebinar panel on your screen? Can you click on that red arrow?
Yep.
Thank you, sir. You may continue.
Yeah, thank you. Thank you for that. Yeah. So having seen that, most of energy is coming from fossil, and where we are spending this energy, and if you want to know how to save energy and how to bring this energy, first we need some kind of metrics where we are, the baseline. Oh, it's not moving. The slide is not moving. Ahmad, I am not able to move this slide forward.
Sir, it's at your end. Can you check your PowerPoint, please?
PowerPoint.
Just
Just a minute.
Can you please click on your screen and then it should work?
These slides, more these slides. Can we come out of this slide and again do this?
Respected sir, can you please click on your screen so that the PowerPoint will be selected, and after that you will click on the mouse or keyboard that the slide will move next. Just click on the slide and it will be moved.
Ahmad, you have my presentation. Can you take control of this? It's hanged. There's an issue in this. I don't know what is that.
Just click on a PowerPoint and then click on from your keyboard to move next.
Sir, can you hear us?
Now it's moved. Yeah. Mr. Ahmad?
Yes, sir.
Are you there?
Yes, sir. Please continue, sir.
It's not responding. Can I proceed?
Yes.
Yeah,
sure.
you can proceed. We can hear you and we can see your screen now.
Mr. Ahmad?
Sir, we can hear you. You can proceed your presentation now.
I'm calling them, they are not responding.
Sir, you can continue, sir.
Mr. Ahmad, can I proceed?
Yes, sir. Please proceed.
We can hear you. We can see your screen. Can you proceed now?
Mr.
You
Ahmad,
can
can you hear
proceed
me?
your. Yeah, we can hear you. And you may proceed your presentation. So you can continue your presentation.
Mr. Ahmad, can you hear me?
Yes, sir. Your voice is clear and your presentation is also visible and it is moved to next slide. So you can continue, please.
So we can hear you. You can continue your presentation, please. Hello, Ralph, can you hear us? We cannot hear your voice. Are you there? So you can continue your presentation, please.
Hello, sir. Can you hear us?
Hello? Is there any issue? We can continue. Yeah, right. Okay. Yeah, let's come back. There is some technical issue. Okay. Uh, yeah, now we are talking about energy productivity indicators. A lot of work has been done by UNIDO in collecting a lot of information from industries, various industry sector, and benchmark them. Okay, so that we know the gaps. I just quickly show you these slides. Okay, now we can see on these slides for each sector what is the energy performance per ton of production. It can be ammonia, it can be iron and steel, it can be cement, whatever you take it. There is a band of energy performance, specific energy consumption for industrialized nations. These are developed nations. And there is also band for developing nations. And there is a global average. And then you also have a country specific figure. Here I am showing, India figure. And also you have what is called BAT, best available technology. Okay, so this is a nice tool to to know where a particular industry sector stands vis-a-vis the energy performance or specific energy consumption. So this kind of tools enable policymakers, in devising various policies, schemes, programs, and targeting specific sectors. So you see that in many of the cases, the India is very close to global average. Sometimes it is better than that, but definitely when I compare with best available technology, there is a lot of gap. So this kind of analysis is available for all countries For people who are joining from other countries, you can verify with the data published by UNIDO. That will tell a lot of things. So if once we agree that there is a gap in energy performance and we want to improve, now what are the things to do? Generally, what we do, the traditional method or the the government approach is first educate the users, like what we are doing now through seminars, workshops, training, capacity building, and also to bring in some of the technologies, best technologies on pilot case, on experimental case, to improve the confidence, increase the confidence of the users, industry, and the commercial buildings. And then once that phase is over, parallelly we can also have a legal structure, to enforce, to give little more teeth and enforce this kind of standards that will bridge the gap between the present performance and some kind of expected performance. So that kind of legal structure has been worked out in India in the form of Energy Conservation Act 2001. The immediate when India's, these are other slides giving information about various sectors. This I will skip it through. Okay. Later you can go through leisurely. You can download and leisurely. Yeah. So these are the key thrust areas of India under its Energy Conservation Act. So few things India has done immediately after when this act was enacted in 2001 is to design a professional certification course, certified energy managers and auditors, to increase the number of people who are aware and who are equipped with various tools, to assess various equipment performance like that. That's the immediate step. So that will bring in a lot of professionals into this sector. So which will be required from later point of the time. And parallelly, it also introduced the standards and labeling for various equipment that are used in industrial, commercial, and residential through its standards and labeling program. So India adopted this comparative label where each equipment which are mandated for this labeling will be rated on a 5-star basis, 3, 4, 5-star basis. So these equipment which are listed, here, like air conditioners and ceiling fans, fluorescent tube lights, distribution transformers, room ACs, okay. All these kinds of equipment now, these are mandated, and geysers, these are required, mandatorily required some kind of star rating. Without star rating, no equipment from this list can be manufactured, no equipment can be imported and sold in India. And similar schemes are there in other countries also. So once you say that certain inefficient equipments are not available in India for for use, cannot buy them from the market, they are not available. So automatically it brings a lot of efficiency culture, starting from the residential sector, from home. So for example, I'm using a 5-star geyser, I'm using a 5-star air conditioner. Okay, so this is what this kind of standards and labeling will bring in. So these are the some of the labels you can see when you go to any shop that sells these equipment. And very easy, because you don't have to be an expert. A common man can go there and he can equally compare. Out of 5-star, my equipment is 4-star. So he knows that still some more efficient equipment is available in the market. So he can inquire, and if it is affordable for him, he can buy it. So this is an information instrument working fine in India and bringing a lot of efficiency into the residential sector and commercial sector. Next thrust area is energy conservation building codes. Now the main focus is on energy and to some extent on water also. The idea is most of the buildings, these are design standards. This is not for operation. Operation separate scheme is there. I will come later. But when buildings are constructed, so this mandates that they follow certain codes. So that we will come later when we talk about building sector. Yeah. Now we are coming to another major program that India is implementing presently. It's Perform Achieve Trade. It's called PAT, targeting various industry sectors. Now 14 sectors are under this scheme. All the factories, units that come under this sector, under these various sectors, they are given a target based on certain baseline studies, and it is a market-based instrument. For example, a cement unit is given a specific energy consumption target, and they are given a period of 3 years to achieve those targets. If they achieve it, well and good. If they don't achieve it, then they can purchase energy saving certificates from the market. How these energy saving certificates are available or generated? These are generated from the plants, other plants which have achieved the target. So if you are achieving a target, overachieving, your specific energy consumption is less than the target given to you, that difference is manifested as energy saving certificates, and that you can sell in the market, and people whoever wants they can buy it. And third point about this scheme is that either you achieve it with your own action or you buy from the market, and if you don't do these two things, these two are compliances. If you are not complying, then it will go into the penalty, heavy penalty. Okay, so lot of teeth is given under this Energy Conservation Act to implement these standards, labeling, and these norms. Energy standard labeling, that is separate from standards, because you cannot put a standard for Indian industry. Its vintage is different, technology is different. Okay, the O&M practices are different, the OEM consideration is different, site considerations are different, the products also sometimes different. It's not same product, same sector, but it's not the same product. So the targets, when we are talking about industry, the targets have to be the unit specific, the factory specific, and then from there, every 3 years, these factories industries get their targets and they try to achieve it. Okay, so these are the why these standards and labeling, and then ECBC, and then PAT. Now PAT also include not only industry, even for the commercial buildings, because the technologies keep on changing. So even an energy conservation ECBC compliant code, which is built, let's say, about 5 years back, now because of the technology development, there may be a lot of scope for improvement. So even the commercial buildings are included in this PAT scheme. So the idea of the key thrust areas under this act is to give some legal framework to and help the creation of demand for energy efficiency products and services. See, from a policy maker point of view, a policy maker or government, they cannot go to each and every industry or commercial building and say that you implement this. They cannot prescribe some technologies. But what can they do? They can do is they can focus on some output. Your specific energy consumption should be like this, and do whatever, because you are the expert. You are running the industry. You are the expert in your equipment. You are the expert in technology. So better you only achieve by way of investing or by way of improving the operations. So it does not matter. It need not be an investment. Okay. So whatever is required, you only do it. So this is the top-down approach. Coupled with this top-down approach, only when top-down approach is there, we are also culturally more tuned towards this top-down approach. Unless there is a rule to wear helmet, we don't wear the helmet, fully knowing that an accident will be fatal, can be fatal for us. So it's both top-down and it's also bottom-up. So bottom up, I'm not put because that is lot of through commercial entity, Energy Efficiency Services Limited. The government is also doing a lot of bottom up approach. Water efficiency program is there, trigeneration is there, solar PV is there, and then solar thermal is there. Then recently they launched for commercial buildings HVAC retrofit program. Municipal energy efficiency program is there. So that's all bottom up approach, but this is more effective. It's working good in India. So from here onwards we'll go to this industry sector, what we can do. So here I have put up some of the common energy efficiency technologies that are that can be applied anywhere. It doesn't matter whether it cement plant or whether it's a refinery or whether it is iron and steel, because those technologies are very specific. They are licensed by certain technology developer. If you go into deep into the process, that's a licensed technologies. And the original licensee, the technology developer, will be working continuously to improve their products, bring in some retrofits, new products like that. But we are not talking about those things, not specific to any sector, but these are the things like energy efficiency motors, and then application of VFDs, okay, that can be for pumps, fans or compressors. Then high COP chillers, then you can use Internet of Things and energy analytics. Okay, so we just go one by one into these things. So coming to energy efficiency motors, we have an International Electrotechnical Commission (IEC), which gives this efficiency standards: IE1, IE2, IE3, and IE4. So long back we moved from IE1 to IE2. We don't use, at least in India, now we are not seeing any IE1 now, except when it's very old motor bought some 20 years, 30 years back. But now this IE2 is now commonly used in India, high efficiency motors. Now the government is pushing for the next level, IE3 and IE4. So these are the efficiency standards. Just to explain you in brief. For example, let us take this one motor, 37 kilowatt PHD motor, 4-pole motor. IE1 will have a 91.2 efficiency, and you can calculate at full load how much energy it can consume for a period of 1 year. So if you take 10 hours per day and 360 days it is running, so you can calculate how much energy you can, this simple thing, 1,46,000 kilowatt hours. Now same thing, if I use IE3 motor, it will have a 93.9% efficiency. So that means it's about 2.8% improvement in efficiency or 2.8% reduction in energy consumption. And then if you use IE4 motors, it will have higher efficiency. Its efficiency is 95.2. So India has got now a high efficiency, motor replacement program, spearheaded by Energy Efficiency Services Limited. So next comes the VFDs. Many people in industry knows that VFDs can be applied for applications. It can be a variable torque load applications like pumps and fans, where maximum saving is possible, because this variable torque equipment follow what is known as affinity loss. Okay, that means if you want to regulate your flow, it is directly proportional to the speed. You regulate the speed by changing the frequency of your electricity fed to the motor using VFD, and it's proportionately the flow will change, and commensurately the head and power also will change. Okay, so head will change with the square of the flow, so that's much more reduction is there. And power, if you see, power will change with the cube of the speed. So if I am saying that your regular way of regulating the flow, controlling the flow, is a throttle valve or a damper for the fans. Suppose I am saying that 20% I want to regulate the flow. That means 80%. 80% will be the new flow. So by reducing flow from 100% to 80%, my power consumption will be 0.8 cube, 0.8 into 0.8 into 0.8. That will be about 48 to 50%. So that means half the power I will reduce. That is a huge impact. Now, only catch here is the head also will come down. So now, if it is your application, your requirement, pressure requirement is not not allowing such reduction, then you cannot reduce that much. You have to settle with not 80% reduction, but reduction to the extent it is the pressure is sufficient for your application, and balance you have to anyway do with your damper. But mostly the practice, we have seen that there's a good amount of energy savings. Now VFDs you can also apply for other constant load applications. For example, crushers and conveyors. This dead weight is so much that whether you put on a conveyor or a crusher, whether you put 100 tons or full capacity is 100 tons, even if you put 50 tons, it doesn't matter. You still consume same power at that particular speed. So these equipment are almost constant torque requirement, and here the power consumption reduces proportional to the speed. So energy consumption, the reduction in energy consumption is proportional. So you may not have energy savings what you expect from other variable torque load applications. But the point I want to make is you can apply for both variable torque and constant torque if the financial viability is there. Ultimately we will be looking at payback period and return on investment like that. So this is one case study of a cement plant, raw mill fan, where VFD's application has taken place. They have replaced the traditional GRR grid resistance method that is there for slip ring motor, okay, which is a resistance. So it's a loss. Compared to the loss in VFD is much lower. So there is 166 kilowatt of savings. It's a big motor, so savings also more. So the GRR itself is an efficient one because it also has a variable speed up feature, but in a steps. It's not a smooth control, but the control happens in steps. So compared to that, but not only steps, but the resistance also consumes some power. So compared to that, we have VFD, okay, which saved some 1666 kilowatt of power. So the point is, even if there is a feature, controlling feature, still we can study little bit deeper and see whether the VFD fits into there. Yeah. Now we are talking about chillers, ICOP chillers. Now, if you go to any this lead standard on the buildings, ICOP is defined as more than 5. So if any chillers more than 5, coefficient of performance is more than 5, that is called ICOP chillers. So under ECBC codes and other rating systems, these are mandatory. So whenever if you are buying some chillers, you can think about these things. Now the third point is use of IoT and energy analytics. Basically, we are using the latest technology, reduction in cost of sensors, reduction in cost of communication that has taken place. In fact, such communication is what is making this this webinar feasible. We are sitting somewhere and you are sitting somewhere, the organizer is sitting somewhere, but we are able to collaborate here and conduct this webinar. So similar technologies can be used to bring these the performance data of various industries. It can be equipment, it can be a department, it can be a section, or for the whole industry. Okay. So this can be used. Okay, so here you can see it's a software soft drink manufacturing plant. So it will tell how much is for water purification, how much for the filling. Okay, so this kind of things will help in regularly monitoring, and it gives lot of operational intelligence to the plant operators. So he doesn't have to do any analysis later, right? In the real-time basis, that what is my present performance, whether it's okay. So if it is in red mode, if it is going, this indicator is going a little bit towards the red, that means he has to take some kind of action. Yeah, so these are some of the slides related to energy analytics. I will quickly skip these things. Okay, so whenever you have suppose multiple compressors, okay, so that specific energy consumption is there, so it will help you to schedule also. Okay, so initially you will operate an equipment which is with lower energy consumption, and then if load increases, then you can go for the other. So it will helps to make such decisions on a real-time basis. So these are the things, some of the things. This IoT also can be used to bring all the details about various plants, various systems, various utilities also. You can connect your cooling tower performance data, pump performance data, chiller performance data. Any data you can bring it, and it can be seen by your operators, your HOD, your technical services department sitting at corporate offices, or it can be shared with your OEMs, it can be shared with the consultants for a quick solution. The other technology nowadays people are talking about is pressure reducing turbine. So steam turbines, we know that they have been here for quite a long time, but with a high pressure and high temperature. But now we have a small turbine starting from maybe 50 kilowatt like that, which will operate with a very low temperature steam also. Okay, so generally any process industry, if you go, the boiler will generate steam at around 10 kg. But if you go to any end user equipment, there will be a pressure reducing bar, PRV. So the pressure is reduced to about 3 to 4 bar, 3 to 4 kg, and then it's given for the process, mostly for the heating purpose. So this 10 to 3 bar, it's a pressure reduction to a valve, so it does not produce any useful workout. Okay. So instead of this pressure reducing valve, now because of the technology development, we have smaller steam turbines which will operate and produce even small amount. Even if you are producing, suppose typical fertilizer plant or typical pharma plant, if they're having about 5 PRVs, okay, even if you are producing 100 kilowatt, 200 kilowatt by installing these things, so this will save, because this is a free power, this will save on your electricity costs. So this is a block diagram. The turbine will sit parallel to your PRV. So this PRT is pressure reducing turbine and PRV is pressure reducing valve. So it will sit in parallel. So and any disruption or any load variation that can be handled through this arrangement. The next one is heat pump. Heat pump is nothing but your thermodynamically, if you see, it is a reverse of your refrigeration cycle. Your refrigerator, what we do in air conditioner refrigerator, we are more interested in cooling. So we are more interested in evaporator. But if you want to generate hot water or hot air, you can concentrate and on the condenser, because condenser is where your heat of compression, okay, that is dumped. So this heat is a summation of both your motor input, also your evaporator heat. So for a 1 unit of electrical input, the output will be much more. So if you are let's take a immersion heater. If you are giving 1 kilowatt hour, it means only 1 kilowatt hour, because that's going directly and producing heat. It's not an immersion heater. Okay, so if you here, the thing is, if you are giving 1 kilowatt hour as electrical input, the output what you get in condenser is much more. Okay, so 4 times, 5 times. So this is the beauty of this heat pump. So you can generate hot water or hot air for heating applications. Okay, so this is a simply reverse of refrigeration cycle. Then we are talking about heat pipe. Okay, heat pipe, you can see on the picture. It's a concentric kind of pipe arrangement. There will be a wick or a mesh kind of arrangement will be there, and liquid flows. Okay, so if you are handling let's say very corrosive hot gases, and you want to recover heat from that, if you put normal kind of heat exchanger, shell and tube, this kind of array, so in very short span of time, the corrosive nature of these hot gases will eat away that heat exchanger. And suppose if you are handling some kind of poisonous gases, then there is a chance of mass transfer also through leakage of pipes in shallow tube. Okay, so such corrosive nature or poisonous of gases, if you want to recover, like for example, like incinerator. Okay, incinerator, you cannot put a normal heat exchanger there because the gases that are coming they are not good for health, so it has to be let out through chimney only. But you also know that a lot of heat is being wasted there. So such applications, the heat pipe is the best. Here what it does is, one side you can see hot heat in, so that like liquid gets heated there and it travels to the other part, which is outside the which will be the outside. So this hot vapor comes out. Here we have the condenser, where suppose we want to heat some water, so we will have this condenser with that water flowing. So this water will absorb that heat and condense that vapor. So he and the vapor and it goes back again into the heat pipe, into the hot zone. Okay. So this is the beauty of this heat pipe. The famous Spirax or Sarco, these people are offering. Okay, many applications are there. Okay, so now let's come to water vapor absorption systems. Now you know that most of the refrigeration and air conditioning systems are vapor compression. It requires a motor to drive a compressor. Okay, and so for that you need electricity. Now if you are having any waste heat source or low cost heat source, so vapor absorption system is the solution. So this is, in fact, as a technology, this is much older than vapor compression system. This is the first refrigeration cycle used in the industry well before the vapor compression was invented. Okay, so only thing is, once electricity use came into existence, it has become very easy, so we started using vapor compression systems. But this is a very old technology. Okay, so here you can give 90 degrees hot water, you can give steam for running this. You can also directly fire if you have any low cost fuel. Okay, you can fire the gas, you can use the flue gases. Okay, so anything you can do and run this refrigeration system. You can produce both +0 and -0, depending on what kind of refrigerant you are using, whether you are using ammonia or using lithium bromide, like that. Okay. Now based on this SWAM, now people are talking about high generation. So this is nothing but we know the cogeneration, that is producing both heat and power. Steam we have as the source. Instead of directly sending this for the process requirement, before sending we try to recover some power, and then extraction steam will go to the back pressure, will go to the process. So that is cogeneration or combined heat and power. Now it is not only heat. If you deploy a VAM here, it can also produce cooling. Okay, so it's heating, cooling, and power. Now the systems are available as trigeneration. For example, if you go to any hospital, and if you employ this kind of a diesel engine, big diesel engine, run with a gas or oil. Okay, now the gas engine or diesel engine efficiency is only 40%. So if you want 1 megawatt power, you have to give 2.5 megawatt input. So what is happening to other 60%? So 20% will generally go as a waste heat through exhaust, engine exhaust. So which may be at 250 degrees, 300 degrees, whatever, or sometimes bigger. If you don't have any other heat recovery, it can be 400 degrees also. So that can be you can put a VAM there, you can put a small steam generator there, or you can put a small heat exchanger to produce hot water there. Up to your choice. Similarly, another 20% comes out as in jacket cooling, water at around 85 degrees, 90 degrees, right? Even that water you can use to run a VAM and produce chilling. Okay, so here you can see this engine. It is producing power. It will produce cooling, chilling from jacket cooling, and exhaust. It's up to you. You want to produce steam and run a turbine? Yes, those systems are available. They have been used for a long time when diesel cost was less compared to the grid electricity cost. But now it's not used. Again, we are getting a lot of gas. So again this the concept of trigeneration has again come into the focus. So this is a technology. You can produce n number of types of energies. So this is the technology. The last one is organic Rankine cycle, ORC we call it. Okay. Basically, this is applicable when you have a low grade energy. That means low temperature energy. It can be a flue gas, waste gas. It can be a geothermal energy, hot water you have. So here idea is they employ a substance which is like a steam, water. But water, we know its properties, we know it boils at a certain temperature depending on the pressure. Here this substance has very low boiling point. So even if you give 90 degrees also it will boil, and that vapor will drive a turbine or expander, and then produce power. So Rankine cycle is what drives what is used thermodynamically in a steam turbine. Here the organic Rankine cycle means the working fluid is not water or steam, it is some organic compound. So it's organic Rankine cycle. So many of these technologies are now being deployed in industries. Now we will quickly come to our building sector. So building is a bit easy from energy assessment point of view. You have major chunk taken by HVAC, compressor, chilled water pumps, then AHUs, and then comes the heat. Now, why we are suddenly interested in buildings is now one estimate when India was discussing introducing this ECBC into the country. The report says that whatever buildings we have, they are nothing in terms of number of square foot coverage. So much more buildings are going to be built by 2030, much more. Okay, so if new buildings are coming and with all kinds of new gadgets, new technologies, or new requirement, I would say that now buildings are not built without air conditioning. Earlier, the most of the government offices in India are without air conditioning. Most of the movie theaters were without air conditioning. Most of the shopping complexes, now we are calling it as a malls, are without air conditioning. But as our standard of living increased, we want things to be in a different flavor. They have to be presented to us in a different flavor. So the business is now done in a different way. Okay, so Here HVAC is a major energy consumer. So if more buildings are built in next few years than what it exists today, then the energy consumption is going to go up. So how to address this problem? So it is addressed by what is known as ECBC, that will come later. But if you see building energy system, you can have an approach like tier 1. First, you try to avoid the heat. Is a heat gain or heat loss? Heat here means both cooling and heating. Cooling and heating. Okay. So if we are in a hot climate, we try to avoid the heat gain. If we are in a cold climate, you try to avoid heat loss. Okay. So heat avoidance, how you can change your orientation of the buildings. You can have limiting your windows, what you call fenestration. You can have sunshades. You can have boxing boxes around the windows. Okay. So these are the things that will avoid heat exchange between the building and the environment. The second tier is you have a passive cooling. That means you can use some kind of natural ventilation. You can have bricks that are good at resisting the heat transfer, okay, or other materials that are available. Okay, this is a passive heating or cooling. And then once you minimize these interactions, then whatever balance is there, still balance will be there, because when you are living there, your metabolism also produces some kind of heat. Or if you are doing some work, the equipment there, that also produce some heat. So that has to be removed. Okay. So then we use the mechanical ventilation. Again, we go to high chillers and all those high efficiency chillers and all those things. So so this is the ECBC code classification, energy conservation building codes. They are applicable to shopping malls, hospitals, assembly, religious places. Okay. Now the classification is if it is more than 30,000, it is large, and 30,000 to 1,000, 10,000 square meter, it is small, and less than that 10,000 it is medium, and less than 10,000 is small. So the requirements under ECBC also, they are different depending on this category. So it's not fit for all case. Okay. So they have considered this sizing, and India being located in the spread over different what do you call weather zones. So what government of India says is only a guidance, but individual states of India, they have their own ECBC codes depending on the local weather conditions and local technology available and local materials, building materials available. So it can be only stricter, it cannot be a lenient one. Okay. So when we talk about ECBC building, what it is targeting is a minimum energy savings of 25%. So this is not a theoretical thing that we are doing. Now you have to demonstrate that you achieve 25% savings vis-a-vis the conventional or business as usual building. So there is a process for that, and 25% can be achieved. We have the prescriptive, very normative prescriptive solutions for that. But what happens if somebody is interested in achieving much more? So for them, you have ECBC plus, which targets that minimum 35% savings, and we also have super ECBC buildings which target minimum savings of 50%. So you can imagine what kind of technologies are available to us. If you are targeting 50% energy reduction compared to a conventional building, so this is the level of technology that we have now. It is available to everyone. Any country can do this and mimic this, emulate this. Yeah, some of the points. The ECBC talks about at the design stage, but from operating stage it can be a different one also. Okay. For example, yeah, just skip these few things. Yeah. For example, you can see this slide of design considerations. Generally, these HVAC designs are done by what we call is MEP, okay? Mechanical electrical plumbing people. So the MEP designers. Now, if you go to them and insist that you want very optimized design, if you go to very quality MEP, by spending little more time and the cost, you can save in each segment of this. Okay, so you can save on air distribution system, the pumping system, okay, and the cooling towers and total. So depend if you, it's like a typical building MEP, what the design process is, they have a fixed set of BOQ or BOM. So if you go like that, then the efficiency can be anything. We cannot really guarantee that. But if you insist on these efficiency aspects and customize your design, optimize your design, then this is the kind of savings possible, huge savings possible. Now, from the operating buildings, what else can be done is when building is under operation. Building is already constructed, but even if you use very good, efficient equipment in operations, still again you regularly check your air tightness. Nothing should come out or go into the thing except the designed quantity of air as per whatever air changes. Then you have a mixed mode operation, part of natural ventilation you can use along with natural cooling and natural ventilation along with mechanical cooling. You have electronically commutated fans. These we are talking about ceiling fans. These are BLDC, brushless DC motors. It's a normal fan, ceiling fan. If it is consumed 60 to 75 watts, then this BLDC is consumed only around 26 to 30 watts. So more than 50% savings in ceiling fans. So these are BLDC fans. Okay. So a big program is also going on in India on this BLDCs. Then you have a variable air volume boxes. Okay. So variable air volume, for example, let's consider a office with 5 cabins. Okay, so each cabin is of different size. Each cabin, the personal requirement, the person who is working there, he will have a preferences. Okay, depending on his age, depending on the type of work he is doing. Okay, so sometimes he may require a lower temperature, sometimes a higher temperature. Okay. So this variable air volume boxes technology will enable to set up different temperatures for different locations or zones or cabins. So accordingly, the variable amount of air is pushed, supplied into that cabin or zone. Okay. So, for example, if I'm sitting in an open office, I'm having fever, even if put 25 degrees, I may be feeling little uncomfortable. I may need 27 degrees. So if I am having a cabin, then this is possible. My cabin will have a VAV box. I will set up only 27 degrees for me. And VAV also will enable to influence people. We can, somebody is setting a lower temperature, 22, we can go and plead him, request him, boss, you please increase your temperature. But in an open office, common office system, this kind of thing is not possible. Yeah. So such technologies are available. Okay. And then heat recovery, ventilation. Okay. So heat recovery wheels are available. For example, the return hair which is going out maybe at 27 or 27 degrees, and outside air is, let's say it is 30 degrees, 35 degrees. You can always use this heat recovery wheel and reduce incoming fresh air temperature, let's say 27 or 28 degrees, and then it enters your normal age. Okay, so heat recovery wheels are also used in buildings. Then solar cooling is there. Okay, we spoke about absorption refrigeration, absorption machine VAM, that requires minimum 90 degrees, 85 to 90 degrees water heat source. But solar based cooling also is available. You can produce water at 65 degrees or 60 degrees, and what you can run what is known as adsorption. It is not absorption, it is adsorption, AD. Okay, so similar to absorption only. Here the setup is everything same, but only we use a low temperature heat, and the substance, the chemical substance that we use in the system is different. That's about solar cooling. Then you can use insulated doors. Okay, and then coming to lighting, you have LED lighting, and then controls you have occupancy controls, daylight, dimming, and then flexible lighting, like alternate lighting you can have. Okay, many of the corporate offices or the which I've seen, most of the MNCs in that are operating in Bangalore and Hyderabad and Delhi. Whatever I am speaking now, they have all these things. All these things. Nothing is high tech here. All these things you can see in operation in any of these buildings. Yeah, solar hot water, if you want to reduce some of your consumption, and submetering. Submetering only helps to have a control on individual sections or individual departments. So some kind of control is there. Then energy efficiency appliances. Then we have costly electrical energy storage. We are talking about storage because when grid fails, the immediate and traditional ways to switch on our DG sets. But thanks to our battery technology, lithium-ion technology, we can have now we can run the high power loads such as the pumps or compressors using these batteries, huge batteries. Okay. So the idea is you can store this energy which is drawn from the grid. You don't have to use very high cost electricity generated from the diesel plant. So some installations are there, but still the technology is compared to diesel set, it is expensive. Then waterproofing is there. Yeah. yeah, building energy management systems are there. Okay, so looking at sitting at your desk, open your VM module, and you can switch on and switch off certain equipment, lights. Suppose you know that a certain section of the office will be vacated at 6 o'clock in the evening. You can just you don't have to go there and switch off and switch on. Sitting at the desk, you can do such controlling operations. You can do dimming also. Yeah. Then building management analytics also there. Then way forward, we are also talking now about self-learning buildings. Then we are talking about use of simulation for energy efficiency. That is already happening. And then green leasing. So based on it's not just so many dollars or so many rupees per month rent, but the leasing or the leaser also will guarantee certain performance, energy performance. Okay. So these are the concepts now that are coming up in building sector. Okay, so I think with that I concluded. I have a small 4-minute video.
Air conditioning accounts for nearly 70% of energy consumption in buildings. The conventional air conditioning systems use either an air condenser or a cooling tower to inject building heat in the atmosphere. These systems have higher energy or water consumption. This range of geothermal-based air conditioning systems offer a solution to these problems. The innovation changes the process of heat rejection by exploiting the fact that the Earth retains a constant temperature throughout the year, a few feet below the surface. In a tropical climate like India's, Earth has a temperature much lower in the summer season than the atmospheric temperatures. The innovation utilizes this lower and constant Earth temperatures to improve operating efficiency of air conditioning systems. The building heat is channelized through a water loop in the air. The water flows through closed-loop piping system, which can be described as a geofield. Additionally, the innovation can take benefit from the moderate amount of rainfall across the country. The harvested rainwater, when evenly distributed in the geofield, requires lower heat transfer area and allows quick dissipation of heat away from the geofield. If the implementation of this innovation in both new building projects and in retrofitting will be accelerated, there is a potential to reduce greenhouse gas emission by about 20 million tons worldwide by 2022. This innovation has the potential to provide greener options for space cooling in the fast-growing building sector. Thus, development can take place with minimal environmental impact.
I think next slide. So that is the end of my presentation. Thank you for your patient hearing.
Thank you, sir, for your comprehensive and informative presentation. I'm sure it has educated our target audience. For now, we'll
Mr. Ahmad?
take a few questions. Yes, sir. Hello. Can you hear me, sir? Sir, can you hear me?
Mr. Ahmad,
Yes,
I have
sir.
done my presentation.
Yeah. So, sir, I would like thank you for your presentation. So, I would like to ask you a few questions that we have received related to your presentation. So, the first question is, you mentioned about the different efficiency motors, the IE1, IE2, IE3, and IE4. So the question is, do you have any information related to the payback period for changing motors from IE1 to higher grade efficiency motors? So can you hear me? Uh, Due to the time limitation, we'll now move to our next presenter. Next presenter is Mr. Sayed Waqas Arshad from K Electric Pakistan. The topic of his presentation is electricity conservation, where we will be talking about the initiatives taken by K Electric to promote energy conservation among its key consumer base. Mr. Waqas has professional experience in electric utility and management solutions. At K Electric, he currently works in the energy conservation and efficiency team, managing energy audit and energy management system as per ISO 50001 guidelines for internal and external stakeholders. He has also worked on various projects across Pakistan related to energy efficiency, building management, and lighting control system for residential and commercial consumers. He worked on KNX-based Schneider energy management system and its implementation at various stations. Mr. Vikas is passionate about energy management systems and energy efficiency, and recently worked on lead projects for KE and projects. Mr. Vikas, thank you for joining us today to share your take on energy conservation. Please proceed with your presentation.
Thank you, Ahmed. Can you hear me now?
Yes, sir, we can hear you properly. You can proceed now.
Okay. Good afternoon. Thank you for giving me an opportunity to share our initiatives regarding energy conservation and energy efficiency, especially what our company KE has been done in this area. I would like to take a moment to introduce myself. As I'm Waqas Arshad, working as an lead auditor in Energy Conservation Department, K Electric. I'm a professional electrical engineer and working on various energy efficiency and management projects. Now we will start or moving on the basic presentation. Before this in this slide, yeah, the global demand is as we know, the global demand and energy electricity is increased day by day. In this figure you can see the Europe demand in 2008 is contribute more than 80 or 90%, but going towards in 2012, from 2008 to 2012, the demand is increased, but the region, the Europe, the shift his demand towards energy efficiency or adding some renewable energy, alternate energy to optimize their generation, or or to add the energy efficiency in their system, because the energy efficiency and the renewable energy are said to be the twin pillars of sustainable energy. The so through this we set the baseline of the today's session. Now I'll give a little bit introduction about K Electric. K Electric is Pakistan's only vertically integrated power utility, and we understand the importance of conservation. We continuously strengthen our generation efficiency to reduce our cost and the reduced carbon emission or something sustainable energy. Our department, energy conservation, is playing a vital role and providing free of cost some services regarding energy efficiency. We'll share you in next slides. Our efforts includes some areas. First one is energy audit. We provide energy audit service to our consumers by conducting physical site survey, the inspection of their load, and suggest the best available energy efficient solution for the consumer for their operational areas and administrative loads like lighting, air conditioning, and other administrative loads. The second one is power factor. Power factor, you know, it is very important parameter for utility and consumers. Our team, our experts conduct surveys for industrial consumers whose power factor is lower than the standards, that is the zero 0.9, and help them to in maintaining their power factor up to the standards to optimize the bill or to reduce their losses. The third service regarding solar PV system. You know that the solar PV and wind are renewable energy. So KE promote sustainable environment, and we provide the solar system consultancy for our big industrial consumers to implement grid-tied solar PV systems or hybrid solar systems at their premises and run their load by this renewable energy. Now the net metering, you know, the consumer avail the billing benefits if they install grid-tied system at their premises. So K Electric facilitating the customers for the availing of net metering process for residential, commercial, and industrial consumers. Now in energy efficiency, we also working on building plants, energy efficiency projects like some accreditation, some standards, some international standards for the implementation of smart systems, industrial automation system, building management systems, some controlling features, and we also work on the water resource and other resource optimization projects. The last one is outreach awareness function. We enable our consumer to conserve energy and attain efficiency in their lifestyle through behavioral change or some basic tips regarding energy efficiency for educational institutes, for some other students, and change their lifestyle by energy saving tips. So these are the six functions where K Electric energy conservation departments working for the energy efficiency. Now, what is energy efficiency? You all know the energy efficiency means doing more with less energy, squeezing as much useful power and out of as little energy as possible, and not letting down the go waste to minimize the energy waste. So for energy achieving or of energy efficiency, we should limiting the growth of energy consumption, not for the benefits, billing benefits, to save the wildlife habitats, safeguard the planets, and reduce the carbon footprint. You know, the more natural resources like oil, coal, gases are used for the generation, the carbon emission, carbon footprint, and the global warming issues are increased. So the more carbon emission are pumped into the atmosphere, the more natural resources are depleted. So we need to reduce our reliance on these energy resources. So one way to do that is to make sure all use energy as an efficiency as possible, through energy efficiency in generation and distribution, through some technological advancement. Some areas we will highlight it, that some areas and available for the energy efficiency in industrial and commercial sectors, like lightings. We will replace conventional lighting by LEDs to save around 60 or 70% energy. Air conditioning is a major contribution in any commercial building or any industrial sector. We have inverters technologies, VRF, variable refrigerant flow technologies are available to save energy, to optimize the air conditioning load. The efficient solution for high inductive loads means motors, compressors, heaters. The efficient and effective solutions are available, like VFDs, like harmonic filters, to minimize the harmonic losses. VFDs to operate the same rating motors in required RPM. Fourth one is alternate energy, renewable energy, wind, solar. If any industry or commercial sector have a provision to install renewable energy. Process automation, industrial process automation. Leading to industrial process automation means that you will use PLC, some logics, some controllers to optimize the process, to optimize the time as well as energy. Then heat rejection sheets, rooftop insulations. Heat rejection sheet will help to optimize the air conditioning load by to reduce the leakage. The rooftop insulation will also help to in reduction in energy in air conditioning consumption. Then we have building management system. Building management system in any commercial buildings, you will monitor the consumption of each floors, each buildings, and then set the and add the some controlling features like motion sensors or automation, centralized monitoring, centralized controlling. So these are the some technological advancement available for the achieving of energy efficiency in industrial and commercial sectors. Now we will share some energy audit process for our industrial and commercial consumers. Some basic steps or some process stages are go through this. First one, consumer can contact us through the portal or some outreach activities to avail these services. Then we set up a meeting with consumer to explain the entire process and set the timelines for the physical survey, and we will share the benefits, associated benefits of energy audits, industrial energy audits, energy efficiency. Then the third one, pre-survey data mining, pre-survey in pre-survey data, some data required by the consumer, such as the layout, the connected load, billing profile, and some consumption pattern. Then we have conduct the field survey. In field survey, we analyze the connected load with the help of our tools, power analyzers, and other electrical tools whenever required, and collect the field data through our experts, lead auditors. Then in fifth step, post survey analytics, we evaluate the current energy pattern and compare it with international best practices. Consumer and engage the consumer with technical experts such as BMS vendors, VFD vendors, and other. Then we evaluate the and analyze the data we have collected in pre-survey data and field audit. Then we put this data in our software, and we analyze the provision of the achieving of energy efficiency. In the last step, in the last step, we present a comprehensive energy audit report with consumers, including some information, reduce energy consumption to perform the same task, some technological advancement with ROI, return of investment with investment plan, with solution providers. And we have conducted these audit as per ISO 50001 standard. We have lead auditors, and we have some basic guidelines as per ISO 50001 and ISO 90.1. So we have conducted this audit as per this international standard. So we not only conduct the audit for any industry, we also help organization, any organization in the process of achieving international accreditation like ISO 50001. For this, we help to develop the energy management policy and help industry team to policy development. Our team ensure the implementation of policies to optimize the load and achieve energy efficiency at all levels to set the benchmark. Energy, as you know, energy management system and any ISO certification have some PDCA cycle, plan, do, check, act. So our team help develop policies and assist the industrial assigned team to finalize the documentation, gap analysis, and some process flow for the implementation, to set the vision, to establish the energy management team, work scope determination, team development, the pre-survey and post-survey analysis. We have conducted the different gap analysis. So we provide all such things for those consumers who willing to achieve these international accreditation ISO 50001 certification. Because this certification is very important if we avail the energy audit service. So you can easily avail this certification with the help of any third party certification bodies. In this slide, we will show the numbers of energy audits have been conducted by K Electric Energy Conservation Department. We have conducted more than 500 energy audits and optimized the load around 60 megawatt. 162,000 carbon footprint has been reduced. The valuable consumers, some consumers are shown in the screen, like IBA, bank sector, government sectors. We have conducted energy audits and they optimize their load. The load optimized in shown screen. As I've mentioned earlier, that we provide solar consultancy to our industrial consumers. These are the consumers who have installed solar PV system at their premises after our consultancy. Our 2.5 megawatt consultancy provided and around 1 megawatt projects are completed. Now we will show some case studies of the organizations who have achieved benefits in terms of numbers from our service and successfully optimized their load. A textile industry, Rajbi Textile, a well-known textile firm in Karachi. We have conducted energy audit and record the electrical consumption data, mainly in lighting, air conditioning, motors, fans, IT equipments. The potential savings percentage are shown in the screen. The potential financial savings, some tangible results are there. The CO2 carbon reduction is there. In this slide, we have seen the monthly average unit consumption before the audit is around 46,000 units. After audit or couple of months or after a follow-up or some post-audit survey, that the consumption goes down 39,000. The savings, monthly savings around 7,000 achieved by Rajbi by the investment of just 0.5 million or 5 lakh. The second one is Asia Petroleum, a well-known petroleum industry in Karachi in Pakistan. The numbers are shown in the slide. The before the audit monthly average consumption is around 234,000. After audit 157,000, and they have installed around 350 kilowatt solar PV system as well to reduce their consumption. And they also installed some VFDs with their motors to optimize their load. The third one is commercial building. Oryx leasing is a type of commercial office type. They have potential to 34% to optimize their load, their energy. In this case, the around 45,000 unit consumption before the audit monthly, and we have seen that the after audit the unit consumption goes down to 42,000. So they have achieved energy efficiency and saved units around 3,000 per month. Just investment by 3 lakh in these energy for energy efficient lighting, energy efficient fans and air conditioning. As we have mentioned in the first or second slide, we also have conducted some technical sessions for industrial associations, for technical institutes, for different bodies, to provide some basic tips for the energy efficiency, industrial efficiency, or commercial building energy efficiency, to inculcate the best practices for the energy conservation. So we have done some kind of sessions in Karachi, like Korangi Industrial Association, and engage with some industrial sectors. So energy conservation and energy efficiency, like services, energy audits, not just for our external consumers, but also K Electric has taken some initiatives to bring energy efficiency in their operational areas, uh, generating stations, grid stations. And we have proudly said that the Bin Qasim 2 plant, or KE BQPS 2 plant, is the first ever plant in Pakistan to achieve ISO 50001 certification. And this plant, the auxiliary load, the 80% of the 8% of the total capacity, will be shift, will be transferred, will be conserved through energy efficiency, like replacement of energy efficient lighting, fans, air conditioning, develop their energy management policy as per ISO 50001 guidelines, and the first ever plant in Pakistan to achieve this certification. Then, not stopping to achieving this kind of certification, are the another plant, name is Korangi Power Complex, also achieved these certifications, and they also developed some policies and shifted the load towards energy efficiency, lighting, AC, compressors, motors, replaced with energy efficient technology. And side gas turbine, our third plant, also certified and achieved this international accreditation. Transformer and switchgear are workshop, KE workshop for the repairing of the distribution transformers or substations. They've also set some benchmark or guidelines as per ISO 50001 to replace their lighting load, implement or add some VFDs with some motor, some inductive loads, and they installed around 300 kilowatts solar PV system to help the optimized or cut down the supply from the obviously fossil fuels or natural gas. So we are not only doing just for accreditation or international certification for plants. We also work for the building efficiency or green building projects. Some initiatives in the Anshawn, we have 2 buildings, IT and procurement. We have installed some building automation system at their premises, including motion sensors, include some scheduling or on air conditioning, to replace the conventional air conditioning by inverter air conditioning. Then we add some automation like scheduling or air conditioning, or motion sensors, or some kind of auto things we have added, and observe around 30% energy saving for their building automation systems. For the solar PV system, we have provide consultancy to our consumers and promote the renewable energy and solar PV system. So for this, to promote the green energy, K Electric head office also installed around 350 kilowatt solar carport solar PV system, state of the art structure, state of the art system, the complete system designed in-house. The energy conservation department have designed their system, their structure. The annual production target for this system is around 3,000 units exceeded. Uh, Now we will move towards the power factor improvement program. As we said that the power factor is very important to utility and consumers, especially utility for the to reduce the network losses. As you know, the problem statement is that the power factor at generation side is 0.9, at transmission 0.85 as per standard, but in distribution, due to the inductive load, due to the variation in load, at distribution end, the power factor goes down. And the kVA rating, the supply kVA rating of the utility cause increase. So for the maintaining of power factor up to the standards, 0.9, if we maintain the power factor up to 0.9, obviously the kVA rating has been reduced and the distribution losses also reduced. Some benefits: voltage regulations, the under voltage issues and under voltage complaints the reduced, the correction of power factor, the reduce the transformer losses, conductor losses, because the power factor is low, the conductor rating, ampere rating, ampacity is increased, the conductor losses will be increased, the power factor is maintained up to 0.9 or 0.8 as per standards, the kVA rating goes down, the same kVA cater the or provide the not the same load, but we can provide more than one or two consumers. Or so for this power factor improvement program, for the network strengthening and to reduce the network losses, we have conducted power factor survey. We have a separate technical team who conducted power factor survey for PF penalized industrial consumers, and we inspect the power factor panel or system of the consumer and provide consultancy or provide some remedies to improve the power factor, like the switching of capacitors to add some more kVA capacitors, or to some issues in automated relay contactors. So our team will conduct physical site survey for those consumers and educate and share some power factor guidelines with consumers to maintain the power factor till up to 0.9 or some standards. In the last, we will share some flyers, informative flyers we distribute to our consumers to follow easy tips for the achieving of energy efficiency. We have some flyers for industrial consumers like LED lighting, some basic tips, payback, energy saving, high energy efficiency motors, automation system, efficient heating and technology. Some flyers we have distribute to our consumers. Some power factor flyers for the general guidelines for the power factor improvement, some immediate steps like installation of capacitor bank, yeah, or educate the sizing of capacitors, proper switching mechanism is very important for the power factor improvement. We have some flyers for commercial consumers like LEDs, ACs, the payback and unit savings in these areas. So thank you so much, Ahmad. Ahmad, can you hear me now?
Thank you. Yes, yes. Thank you, Mr. Vakas, for your great presentation. I would like to take a few questions that we have received.
Oh, okay. Ahmad, can you hear me? Hello? Hello?
Yes, sir, we can hear you.
Ahmad, can you hear me?
Hello, Mr. Vakas. Can you hear me?
Yeah, I want to add just one slide.
Yeah, sure.
Okay. I think you missed it. We are working on the green efficiency projects, and our very first LEED certified building in KE is going on, and in this building, in this building, we have aligned with a professional consultant for the LEED Gold certification, and we set the benchmark and we installed the systems as per USGBC guidelines, like building management system. One of the Schneider BMS have been installed at their premise. More than 60% load means ke around 60 to 70 kilowatt solar PV, grid tied solar PV system has been installed at their premise. So we are working on these type of green buildings and international accreditation, and this project is going on, and in future we add some more buildings for the achieving of energy efficiency and LEED and other international accreditation and certifications for the environmental. Obviously the energy efficiency and green building help to reduce the environmental impact and carbon footprint or something. Now, Ahmad, moving on for QA, question answers.
Okay, thank you, Mr. Vakas, once again for your great presentation. So we'll now take a few questions. The first question is, beside energy audit, have you been working on developing the comprehensive energy management plan or system for industries or commercial buildings? If you have any, can you please share on that?
Okay. So before the conducting of energy audit, yeah, we have energy management plan, or we have the benefits and the benefits is vary from consumer to consumer, and the energy management plan as per ISO 50001 is available for the showing of at this platform. We will share you some plan will develop internally developed by our team for the consumers. So energy management plan will be share you with you, Ahmed.
Okay, thank you. Thank you. The next question is, in the K Energy audit case studies, you have shown us some figures regarding the monthly kilowatt hour reduction.
Yes.
So is that reduction is excluding the solar PV generation, or does that include that as well?
No. The case study has been shown like Asia Petroleum, Oryx Leasing, and Rajbi. The saving is excluding the solar PV system. They achieve the savings or energy efficiency. They're replaced by lighting, fans, air conditioning. In Asia Petroleum, around 350 kilowatt solar PV system has been installed. The savings of from this solar system is excluded. These savings only from achieved from the energy efficient system, lighting, air conditioning, VFDs, and some sort of technology which were discussed in the first and second slides.
Okay, thank you. The next question is, generally, what is the return of investment period for after once the client implements your audit recommendations? What is the return of investment period for different consumers like household, commercial, or industrial?
Yeah, very great question. I think ROI is depend on the technological advancement. For example, if we say that the conventional light will be replaced by LEDs, the payback or ROI will be 1 or 2 months. If we go with air conditioning, the ROI goes up. The ROI will be around 6 to 8 months. If we install the VFDs, the ROI will be 1 or 2 months, and we will install the industrial process automation. The ROI goes up. The ROI of the system is depend on the which technology replaced by the energy efficient solution. Industry industrial energy audits, ROI vary from solution to solution. For commercial, we all know that the air conditioning contribution, the consumption of air conditioning is 80%. So in commercial, the air conditioning will be if air conditioning replaced by the energy efficient or VRF system, the ROI will be depend on the inverter split ACs or VRF VRV system. If we go with VRF systems, the ROI will be 1 or 2 years. If we go with inverter ACs, inverter split ACs, the ROI will be 8 to 10 months. For residential or ordinary sectors, we have some lighting loads, fans, air conditioning. So average ROI for ordinary residential sectors will be 4 to 5 months. But in industry, it is very important. The ROIs vary from solution to solution.
Perfect. Thank you, Mr. Vikas, for taking your time out for today's webinar. Due to time constraints, we will not be able to take any more questions. Thank you for joining us today. Dear audience, we have now come to the end of our webinar for today. I hope that you must have benefited from today's session. I once again would like to thank our speakers for today for taking their time out of their busy schedules, and thank you all of you for joining us today. I would like to reiterate that all materials relevant to this webinar will be available on SARC Energy Center website. You can email your feedback Take care, stay safe, and thank you, and goodbye.
Chalo, very good.